So in the previous part, we queried R1 for some information about itself and its neighbors. Actually, its only neighbor, R3. Among these values, we found out the IP address of R3's directly connected interface, which is 172.16.0.2. Now, the main idea behind this application is to get some information using SNMP from a root device, like the IP addresses of any neighboring OSPF routers, then run the same SNMP get function for those addresses too. This way the entire network will be queried. Now let's look at the network diagram for a moment, ignoring the management links to R2, R3, R4 and R5. So first we query R1 and we find out that its only neighbor, R3, can be accessed using the IP address of 172.16.0.2. Next, using the same function, we query R3 at this address. R3 will tell us that its OSPF neighbors are R1, R2, R4, and R5, giving us the host name, router ID, neighbor ID, and neighbor IP address for each of them. Then each neighbor of R3 is further queried for the same information, and so on, until we obtain a final list containing all the OSPF devices in the network. Now you may ask yourselves if R1 will report R3 as a neighbor and add it to the final list of devices. Then R3 will report R1 as a neighbor and add it to the list. Then R3 will also report R5 as a neighbor, and R5 will then report R3, and so on. Wouldn't we get a list with a lot of duplicates? Well, I'm glad you asked. That is the role of the code in part 4 of this application. So let's see the code. Okay, as you can see, this code is using the first two variables returned by the findUnqueriedNeighbors function. So these ones over here. And when the values of those variables become equal, then it breaks out of the while loop and keeps executing the code below. So this is similar to saying keep querying the network routers until the number of distinct OSPF neighbor IDs becomes equal to the number of distinct OSPF host IDs we found. Or, to be even more explicit, query the network until you cannot find any new OSPF router IDs. Enough about the code in part 4, now let's discuss the findUnqueriedNeighbors function. First, to better understand the code inside this function, let's consider that the OSPF variable stores not just the dictionary for the root device, but the dictionaries for all the devices in the network. Let's see it here and use it as an example. So this would be the entire OSPF list, the value for the OSPF variable. Now the purpose of this function is to get the complete list of host OSPF router IDs in the network, the complete list of neighbor OSPF router IDs, and the final form of the OSPF list of dictionaries, as we see it right here. First, we initialize an empty list, all host IDs. Then, using a for loop to iterate over the entire length of the OSPF list of dictionaries, we can extract each host router ID using the index and the key, host ID in this case. So we are referring to this key value pair for each dictionary. This means that for index 0 in this list, meaning the first dictionary in the list, we extract the value associated with the host ID key. The same is done for indexes 1, 2, and so on. Finally, we append each host router ID to the list we created up here, all host IDs, using the append method. Next, down here, we are doing the same thing for the OSPF router IDs of the neighbors. Iterating over the same list of dictionaries, we are looking at this key value pair in each dictionary, so neighbor router ID. In this case, the value is a list of neighbor router IDs, like this one over here, because a router may have one or more OSPF neighbors. So, this time, to extract each neighbor router ID from each dictionary, we should first iterate over the list of dictionaries, and then, using the index and the key name, over the list of neighbor router IDs. So, this list right here, for example. So for each neighbor router ID in the list of IDs, from each dictionary in the list of dictionaries, if the router ID happens to be 0.0.0.0, then do nothing, pass. Else, for any other value, add it to the list of all neighbor IDs. So, this empty list right here. Next in our code, we initialize another list. Inside this list, we are going to store any neighbor IDs that were found and are not already members of the host OSPF IDs list. So, this list over here. So, for example, when running this function for the first time, we have a single dictionary in the OSPF list, which stores the information about router R1 because this is the root device. At that moment, the all host IDs list has a single element, the router ID of R1, which is 1.1.1.1. At the same time, the all neighbor IDs list has also a single element, the router ID of R1's only neighbor, 3.3.3.3. Since 3.3.3.3 is not registered in the all host IDs list yet, it will be appended to the all outsiders list, which is initially empty. So this list right here. Next, it's time to run the snmp get function for all the neighbors which were not queried, so for each member of the all outsiders list. But the all outsiders list contains neighbor router IDs, not real IP addresses that we can pass to the snmp get function, right here. This is the reason for which we have to iterate by index over the OSPF list of dictionaries, and then by both index and value over the list of neighbor router IDs inside the dictionary located at index R, for example. Now, if the router ID in the all outsiders list, so Q, matches a router ID in the dictionary, that's S, then we extract the IP address located at that same index in the neighbor router IP addresses list and run the snmp get function for that IP address. Else, do nothing. I know this is somehow confusing with all these indexes and nested for loops, so let's see this algorithm in action. Let me uncomment some print statements and then run the application to see the lists we've talked about. So, let me uncomment this one and this one for the all outsiders list. Also this one and this one for the all neighbor IDs list. And finally these two print statements for the all host IDs lists. Let's save the application. 192.168.2.101 public. Let's wait a bit. Okay. So these are the lists printed out. Okay, now, the first time the function is executed, we get the all host IDs list having just the router ID of R1, of course, because this is the root device of the network, and it is the only router queried up to this point. Then we get the all neighbor IDs list having just the router ID of R1's only neighbor, R3. Finally, the all outsiders list is made of the router IDs that have not been queried up to this point, so again R3. Now for this router ID, the program will find the associated neighbor IP address from R1's point of view, and then run the snmp get function for that IP address. That's what this code does over here. Now, back here, at the next run of the function, we already know two router IDs, R1 and R3. Next, we have the updated list of neighbor router IDs found in the network. We see R3, which is the neighbor of R1, and then these four router IDs, which are the neighbors of R3. So, R1, its neighbor R3, then we know about R3 that it has these four neighbors. Okay. This time, the all outsiders list is made of the router IDs which were not yet queried. Since we already queried R1 and R3, we are left with the router IDs of R4, R5, and R2. So this time we will run the snmp get function for each neighbor IP address associated with these OSPF router IDs. Next, at this point, we have already queried all the routers in the network, so the all host IDs list contains all the OSPF router IDs in the network, so all 5 of them. Also, the list of neighbor OSPF router IDs is complete. Let's check it. You can also look at the network topology if you feel the need to. So, router R1 has a single neighbor, router R3. Next, router R3 has 4 neighbors, so R4, R5, R1, and R2. Next, routers R4, R5, and R2 each have a single neighbor, which is R3. So we have a neighbor for each of them, and that is the same neighbor R3. Since we now covered all the routers in the network and there aren't any other routers or new router IDs in the neighbors IDs list, comparing with the host IDs list, the all outsiders list is now empty. So we don't have any other neighbors to query. Now let's get back to the final OSPF list of dictionaries, because I owe you a better explanation for this apparently confusing code right here. So let's consider the second time the function is executed, and we have 3 values inside the all outsiders list, so this list over here. So for Q in this list, let's say 4.4.4.4, iterate over the OSPF list and the dictionaries within this list, so these 2 for statements right here. And if you find 4.4.4.4 in the list of neighbor IDs, so right here in this list, this is the if q equals s statement, then extract the IP address needed to reach that router, which is located at the same index in the list of neighbor IP addresses. So if we have 4.4.4.4 at index 0 in this list over here, in the OSPF list of dictionaries, the corresponding IP address of that neighbor will be positioned at the same index in this list. So the program extracts 10.0.50.1 and performs the SNMP get function on that particular IP address. Now finally, the function returns the list of host router IDs, the list of neighbor router IDs, and the OSPF list of dictionaries. That's it for part 3 of this application. Let's discuss part 4.